morning, class. Today we'll be talking about components of a vector. So what we need to start with the Cartesian coordinate system. So basically you have your x-axis and your y-axis. And this is your point of origin where they cross, the cross section. So anything to the right of the point of origin is in the positive x direction. Anything to the left of the point of origin is in the negative x direction. Anything above the point of origin is in your positive y direction. Anything below the point of origin is in your negative y direction. The Cartesian coordinate is sectioned into 4 sections. The first section is known as quadrant 1, going a counterclockwise direction. And the next one is quadrant 2, quadrant 3, and then quadrant 4. So basically, the same Cartesian coordinate system is represented in a 360-degree circle. The first quadrant is your 90 degrees. The second quadrant is your 80 degrees, where it starts from 0 and ends on 180. Then 270 is your third quadrant. 360 degrees is quadrant number 4. So if you want to come down a little bit. So now we get to components of a vector. So this is how you look at a vector. A vector has an initial point or a starting point, and a terminal point or its end point. So it always goes in the direction of the arrow. So this is vector AB, and this is how it will be denoted. Vector AB with the sign for the vector up the top of the letters. So if you see this sign up the top, you know it's a vector, or another way to signify the vector is if the letters are embedded. So likewise, this vector will be noted BA because it starts on B and ends on A and has the vector symbol. Now we're going to show how a vector is applied to the Cartesian coordinate system. That's how you can determine the components of a vector. So this is vector A, and this is angle theta. So we have a y component. So if you go up 1, 2, 3, 4, 5, that's where on the y-axis, it stops on the y. 1, 2, 3, 4. So your x is 4, and your y is 5. So the y component is also known as the opposite of the angle. The x component is known as the adjacent to the angle, and the vector itself will be known as the hypotenuse. This is where this terminology is applied. So, ca, tor. So is sine of the angle is equal to opposite of the angle over the hypotenuse. So this will be sine of the angle is equal to the opposite, which is 5, over the hypotenuse, which is 5. You know that is 5. All right? Chi is cosine theta, cosine of the angle, is equal to the adjacent over the hypotenuse. So cosine theta, the adjacent is 4, the hypotenuse is 5. Tor is tan theta is equal to the opposite over the adjacent, right? So tor is equal to tan theta is equal to the opposite over the adjacent to the opposite. We can substitute the values. The opposite is 5 over 4. But if you want to find the angle theta, so to get theta by itself, you divide by 10. So theta equals the inverse 10 over 5 over 4. That's how you can find what this angle is. So you can type in on your calculators the inverse 10 or 5 over 4, and that will determine theta. So that's the process for determining the components of a vector. So thanks a lot.